Welcome to my channel, and today this is a very important question for the board exam and competitive exam. And students, see here, most interesting integral. Just we want to introduce to all of you here, and this is here for question number 1, and 1 plus this is here cosec x dx under root. So see the technique of solution here carefully, and this is we can write here 1 by sin x, then take a LCM, then 1 plus and sin x here, and this is here sin x, okay, and dx. And in place of 1 we can write here sin square x by 2, and this is here cos square x by 2, okay. And in place of sin x, this is 2 sin x by 2 into cos x by 2, and this is at dx, and under root 2 sin x by 2 and cos x by 2, okay. See, on the numerator part it will be a perfect square, so you can write here sin x by 2 plus cos x by 2 whole square under root, so it's free from root, and here we can write and see whose derivative is this, and that is sin x plus cos x. This is the sin x minus cos x, so in place of that we can express, this is the format of minus pattern, so this is there we can write sin x by 2 minus cos x by 2, and we want to get these 2 sin x by 2 and cos x by 2. If we split this extension, then we get here 1 minus 2 sin x by 2 and cos by 2, but here is a plus, so doing here is a minus, so we get here 1 minus and added here 1, so it is balancing, then we get the result is this. So now let us assume, let sin x by 2 minus cos x by 2 as a y, so differentiate dy dx, and this is here cos x by 2 and half, take a common half, and minus minus plus, and this is sin x by 2 and also half, and this is their half. So from that twice times of dy it is, and cos x by 2 plus sin x by 2, and this is their dx, so it can be expressed as twice times of dy and under root of 1 minus y square, and this is equal to 2 and dy under root 1 minus y square, and it would be sin inverse, and this is y plus c, and this is sin inverse and y means this is their sin x by 2 and minus cos x by 2 plus c. I think this is very interesting question. I think all of you better understood to see this question here, okay. And now we want to solve the question number 2. This is also a very interesting question, and here the solution. Okay, and same technique, and normally both the pattern are same, but see carefully, and dx, this is dx, and this is cos x plus cosec x, this is dx, and cos x plus 1 by sin x, this is sin x, and this is here cos x sin x plus 1, this is here half, twice time of sin x, 1 plus sin x and cos x and dx, and this is equal to See, this is here 1 plus sin x cos x. In place of 2 sin x cos x, we can write here sin x. We can write here sin x plus cos x, and also sin x minus cos x, and whole divided by 1 plus sin x cos x and dx, and split the partial part, and this is sin x plus cos x and whole divided by 1 plus sin x and cos x and dx, and this is here sin x minus cos x and divided by 1 plus sin x and cos x and dx. See, okay. See, and this is the derivative of, see here, sin x plus cos x and dx. We want to express on the numerator part be in place of sin x and cos x, that is sin x minus cos x. So this is here sin x plus cos x, and if we doing 2 and multiply by 2 here, same as 2, this is 2 plus 2, okay. This is 2 minus doing 2 sin x and cos x, okay. This is here 1 and this is here 1 actually. So actually here is 2 plus 2 sin x cos x. If we express this as a 1 plus, so doing again 1 plus this is, and now we added doing 3 here, 3 minus 1, and this is 2, and minus minus plus 2 times of that. So again 2 into, this is a sin x minus cos x and dx. See, again I want to express like plus pattern. This is a 1 plus 2 sin x and cos x, okay, and 1 is more, so 1 we added here, so balancing this format, okay. Now again see, and this is equal to the ddx of sin x plus, this is a minus, see, differentiate of this is cos x and division of this is plus sin x, okay. So this is here, and sin x minus cos x whole square, and see, and this is the, and this is a 1 plus sin x plus cos x whole square. If we differentiate this is this, and then we get here, we can write here sin x plus cos x, then we get here cos x minus sin x, so this is our minus. So this format is the generalizing pattern. This is, we can express as a root 3 whole square, and this is a 1 square. So this is 1 by twice a. You can write here 1 by twice a. A means root 3, and this is your sin inverse x by a. Okay, I am wrongly written here. This is not a sin inverse. This is not under root. So this is 1 by twice a, and ln mod of this is root 3 plus sin x minus cos x, okay. Again this is here root 3 minus sin x minus minus plus cos x, okay. Again this is plus from this, for this is here minus 2, and this is as a tan inverse, this is as a tan inverse 1 by a. This is 1 by a means 1, and this is a sin x plus cos x by 1 actually. and plus C. This is your answer. Very interesting question. See carefully. Okay, bye everybody.